Okay, so that's the discussion we have started back in February, and today we're continuing this discussion. So we have the disclaimer that this is done on our own time. We are not representing views of any agency, and we're analyzing three sources of data which is available in Canada. One is related to uh, sorry, I see Jason has just joined. So uh, uh, this is very good news. And okay, Jason, are you there?
Yes, hello.
Oh, wonderful, wonderful. So welcome. We have been waiting for you, and we're looking forward to learn more about the Shiny app which you have built. And I'm providing a little background about our activity, our Lunch and Learn. So I'm sharing the screen. Jason, can you see my screen?
Yes, I can. Thank you. And sorry I'm late. I think we just got times a little bit mixed up. Apologies for that.
Sure, no problem, no problem. So a few logistical notes first. So we're using Zoom, and Zoom will shut down in actually in about 25 minutes from now, automatically. And what I suggest that everyone just get back to Zoom. We will continue the discussion. Okay. So just click on the same Zoom link, and we will just continue the discussion. That's number one. Second is, again, I would like to remind everyone that we have two GC Collab groups, which I'm showing on the screen right now. One is a bigger group, which now counts 277 Government of Canada colleagues and partners, and it's open group, and we have a number of different discussion threads there. Recently, I have posted a discussion about ideas. I discussed our Lunch and Learn, and in fact, it appears still that analyzing data related to vaccine is one of the most interesting, because indeed there is so much data coming since the start of vaccination. We didn't have this data a year ago, but we do have this data since August. Essentially, we didn't have it before August, but after August, indeed, the Government of Canada has accumulated lots of data related to vaccines, on safety, on efficacy, and of course, other governments have gathered also a lot of data on vaccine, and this data is very rich in terms of different fields and different numbers. So it provides excellent opportunity for us, the data scientists, to really to make use of our skills, data science, data analysis, data visualization skills, to get some insights from this data, which has been empirically gathered from real application of vaccines to the population. So this is a group, open group. Now we have a closed group, which is called Data Science with our meetups. And it's here in this group where we would actually have a discussion, where we would have questions, answers, where we would post a video, links to a video, codes, and everything. So if you would like to get those, I recommend that you essentially join this group as well. For example, last week or 2 weeks ago, we have discussed another data from Government of Canada, which is cases following vaccination. So indeed, it's also very important, because this data tells us about the real efficacy or efficiency of vaccine when we essentially count how many deaths, COVID deaths, were vaccinated and non-vaccinated. And again, I invite everyone to go to this page, and you would see some discussion there. I'll just quickly browse but you can do it offline. For example, we have shown last time that PHAC, Public Health Agency of Canada, reports data counting cases since December 2020, when there were no fully vaccinated yet. And because of that, they introduced this algorithmic bias, which essentially skews the results significantly by the essentially order of magnitude towards in favor of vaccinated. So when they reported 0.5, only 0.5% of cases were fully vaccinated. In fact, it was not 0.5, it was 16, all right? So we talked about that last time. Now, today we talk about a different source of data, which is reported side effects following COVID-19 vaccination. And this website, you can open it. I have put all the links in the chat. It's very good that any of you can just open it and see this data yourself first, because we're not making up these numbers. We're really getting the numbers exactly from the source. So, and in this figure 1, you can click here, text description, and you would see the actual data set. It's now quite big. You can open it, show all 100 lines, and you can see it counts adverse reactions, all, then for children under 12, for children under 17, and so on. So in order to make it easier for us to process the data, what we have done, and we talked about that last Friday, we have created a spreadsheet. And again, the link to this spreadsheet has been shared with all of you in chat. So it's this spreadsheet where each line, and I'm highlighting right now the line, corresponds specifically to data on that particular date from this report. So from report PHAC1, these are the numbers. And you can see we have all numbers from all reports. The first report on this PHAC1 was issued on July the 30th. And you see all the data there. Now we see a data related to side effects. And when we open this data, you would see a spreadsheet which shows exactly this table. So these are the fields: weekly, serious, non-serious, cumulative, serious, non-serious, number of doses administered. So this information is available, and it is also plotted right here. Okay. Now this spreadsheet has been just loaded, and you would see this data. It's exactly the same table from the same PHAC document, but I just put it in a spreadsheet so it's easier for us to plot graphics. And actually last Friday we've shown you how you can use R, for people who are familiar with our language, how you can get data from spreadsheet. And then of course you can do much more. You can build interactive apps, and you can really visualize many interesting graphs. So what I would like to do now, I would like quickly to review the data which is available in Canada for vaccine safety, and then we'll switch to Jason, and he'll talk about the vaccine safety data which is from United States, because they do have much more detail about all vaccine adverse reactions. But again, we'll start from Canadian data. So this is Canadian data. This is what is reported here. Essentially, you would see colored in different, using different color. These are the columns which show the number, just the number of reactions for children from 5 to 11 years of age. And let's say, unfortunately, PHAC does not tell us more than that. It just counts and how many doses were administered and what is the rate. For example, the rate for children is 3.5. So 3.5 out of 100,000 will be seriously damaged, right? And when, of course, you count this with damage from COVID, you would see that children, actual children from COVID, they have very few, practically none cases of COVID for young children. So the number of adverse reactions for children from COVID vaccine already exceeds the number of deaths from COVID. Now, another field here in red color is statistics for weekly serious reports for 12-17, and then from 18 plus. So that's all we have in Canada. And still, it's quite good because you can plot it and you can see the actual numbers here. And I show this graph. Any of you can go to this web page when you have access to Google Doc and just plot it yourself. And you would see the counts. These are just the counts, right? And you would see that the counts actually already exceed the counts of deaths from COVID. And because specifically for children, it's not looking promising. So you can compare serious effects from COVID versus serious effects from vaccine. And on this page, on this Google Sheet, we have those graphs printed there so you could have a look yourself. Now, Jason, I'm giving the microphone and the screen to you. And I know you spend a lot of time processing the data from the United States government. And how would you like us to proceed? Do you have a presentation, or would you like?
Yeah, I can share my screen. That's probably the easiest thing, Dimitri.
Okay, so I'll stop sharing my screen, and you can share your screen.
Great, thank you. Okay,
Yes.
give me a moment just to set up. I think you need to give me permission so I can share my screen, Dimitri, that's all.
Sure, I will do it now. Can you try to share?
Yeah, that's fine. Got it. Thank you.
Excellent.
Okay, can you see the screen?
Yes,
okay.
Yes, I see your PowerPoint presentation.
Okay, great. So I've only got a couple of slides, you'll be pleased to know, and then I'll go into kind of the interactive side and a bit of code. Apologies, I don't know the audience very well. I've just been invited.
I need to apologize, Jason. I would like to still to introduce you to this because it was great to see your work. You've been doing this work also on your own from United Kingdom, and again, thank you for accepting the invitation to talk to us. And again, just to remind everyone, Jason Morford is a former principal analyst with British Telecom in UK, and he spent 22 years in British Telecom. But now, I guess, Jason, you are retired, so you have more time to you have more time to do something, I guess, what you would...
independent research, I guess you could call it, yeah.
Yeah. So, and Jason has, just as myself, he has PhD in computing science, which is very interesting. Yeah. And the Bachelor of Science in Software Engineering. So as you would see, he is a very good software developer as well. So Jason, again, thank you for accepting the invitation. And now, yes, please proceed with your presentation.
Shut up
Will
and
do.
get
Thank
off
you very
the
much.
screen, you idiot. Goodness.
Okay. So thanks for the introduction, Dimitri. As I say, I'm going to give a couple of slides just as a bit of background. So this is independent work. I'm not affiliated with any organization. And this was really, Cave is an application that I put together as a result of my own personal research and my own personal journey in terms of doing research for risk benefit of having a coronavirus vaccination in the UK. And I'm going to talk a bit about the government official sources in the UK and the shortcomings of that, and what led me to write the Cave app as hopefully something that was a little bit more usable by the general public. So I'm going to talk about three things really. One is kind of the motivation for writing Cave. And that was really my experience, as I said, with the MHRAs, which is the UK's Medicines and Healthcare Product Regulatory Agency. It's the official government regulator. And they have a yellow card system, which is what's used to capture adverse reaction reports. And I'll show you what that looks like. And it's really in response to that I kind of delved into dusting off my R skills, so to speak, and writing Cave. I'll then talk about the official government US data set, which is from the joint CDC and FDA, which is the VAERS data set, which I'm sure some, if not all of you, are aware of. And I'll talk a little bit about that, what it's got in it, what some of its shortcomings are. And then I'll go on to a bit of a demo of Cave itself and a little code dive just into a couple of areas. I've got a couple of links here. I can send these slides on to Dimitri afterwards, which has got some further background. I've also got, I've uploaded it, Dimitri, now to GitHub, so the code is available if anybody would like to have a look at it. I'm not maintaining it. It's purely put out for public consumption, so there's no license on it.
Yeah.
All right. So
just one more comment, Jason. We have just a logistical constraint here. We're running Zoom, so in about 9 minutes, Zoom will end automatically. And please, everyone, just reconnect back, and we'll continue. Okay? So
yeah, that's absolutely fine.
Yeah,
how long have I got, just out of interest, roughly?
Again, if you see if everyone gets disconnected, please just get back to Zoom again. Okay, thank you.
How long have I got, Dimitri, give or take?
Yeah, so you have about 8 minutes now, and then we'll continue.
Okay. So the yellow card system in the UK. The yellow card is the UK's primary pharmacovigilance system. It's run by the MHRA. And this work or my investigations for my own personal risk benefit analysis started about a year ago. In fact, just almost exactly a year ago, as you can see the first data point, where I started to collect the MHRA's data and plot it for myself. And I was really looking, I'm an asthmatic. I actually have a cold at the moment. So I do have respiratory issues, which I needed to kind of investigate with respect to my own personal risk. But what I started to plot was the number of deaths that were being reported, both in terms of the MHRA's yellow card, which is the blue line, and the official government figures from COVID deaths within 28 days of a positive test, which is the orange line. And over time, you can see these two curves starting to converge, which was obviously beginning to influence my own decision. But on the way, I started to find out a lot more about the data, or the lack of data, that was there from the MHRA. They do provide a weekly report, and I'll show you that in a second, just as a glimpse. And it's in a really unusable format. It's in a PDF or a set of PDFs. They produce one for each of the major vaccine manufacturers. So we have Pfizer, Moderna, AstraZeneca in the UK, and BioNTech, Pfizer-BioNTech, obviously. And the PDFs are really unusable, frankly, and I'll show you why in a second. From February to May, I decided to download each of the PDFs each week, because what would happen is the PDF would be overwritten, and I wouldn't be able to look at the delta effect each week of the vaccines. So I needed to capture each and start plotting them. And that's exactly what I began to do. So I'll show you what the yellow card looks like. Just move this out of the way a little bit. How do I get that out of the way? Excuse me. Right, so this is where I'm just going to move it down because I've got the Zoom screen. You can't see this, but unfortunately my Zoom controls obscure the tabs. This is the reporting system for the MHRA. So if there was an issue that somebody wanted to report, they would come in here, choose which vaccine they'd have, and go through a set of forms to report the effect. And I've been through this, not that I've had an adverse reaction, but I wanted to have a look what was in there, what's being captured. And a lot of information is being captured. There's personal information, there's vaccination information, there's where you were vaccinated, when you were vaccinated, which lot you had, when the date of the onset of symptoms, a number of fields describing symptoms, specific fields if you were pregnant. So there's a lot of information that's actually being captured. But if I show you what the government actually publish, it's a really quite poor subset of that. So on a weekly basis, this page gets generated. So this is from the UK government, and this is the yellow cards report. And you can see that there's a different report for the Pfizer product versus the AstraZeneca and Moderna. If I show you the Pfizer one, you'll see the subset of data that gets reported. Now imagine you're a UK citizen, you may have comorbidities, you may have uncertainties about having a vaccination, you may, for example, have had an anaphylactic reaction in the past, and you may be unsure about what the risks for you are going to be. And your only portal into anything that can help you make a decision is this report. And the report, this goes on to 115 pages. This is just the Pfizer one, which looks impressive, but it's completely unusable from a consumer's perspective. It's broken down into major groups. So you have blood disorders, cardiac, pulmonary, et cetera, et cetera. And then there are two subsections on each of the adverse reaction categories that people have reported. And what the MHRA give you is the number of reports that have been received and the number of fatalities. And that is it. You have to make a decision based on that. And a lot of these terms are very clinical, and a lot of people wouldn't really know how to assess it. So what I did was I started to bring it into a spreadsheet to begin with. So this is kind of where I started back in late February. So there's blood disorders, which relates to that heading. And then for each of the remaining headings, I was basically tracking cases and deaths. But I was particularly, because of my own asthmatic situation, I would look at the respiratory disorders, and I'd be looking at the delta of that each week. And I'd be looking at how many events had been generated that were based around respiratory issues and how many fatalities they were. And all the while, I would be tracking these two curves, because the risk benefit to me was trading off against, am I going to die from a vaccine or am I going to die from COVID? What's the probability of either of those two events happening? So I came to the end of this journey and I decided, well, that was really difficult for me to do. And so I thought, well, there must be a better way. And clearly it's not using the MHRA's own data, because it's extremely, as you can see, unwieldy. It's not very friendly for any data analysis. It's written in a PDF format, which is used for publishing, not analytics. And so I started to look elsewhere, and I decided to investigate VAERS. So I looked at the CDC and the FDA's VAERS database, and don't be too kind of worried about this. I'm just going to talk through this really quickly. So VAERS is comprehensive. There are shortcomings with it, but it's predominantly just 3 tables. It's what they call the VAERS data table, and this is all available to the public. I'll show you where that comes from. For example, I go to here, get to VAERS. It's quite well documented. There's a data dictionary that goes with the data. So this is where you download the data. This is the last sort of X number of years since 1990. It's predominantly flu related data, obviously up until the last couple of years, where you can see the size of the The files is quite significantly increased compared to previous years. But this is now publicly accessible. There's what we call the non-domestic set. So VAERS also captures information from other countries. And it has, as I say, it has a pretty good data dictionary that's associated with it. So it's all great, and it's all in CSV format. Great again, good for analytics. So what can I do with that? But there are three basic tables that come with VAERS. There's what's called the VAERS data table. So there are 35 columns of data that sit within that. It has a primary key called a VAERS ID. It has a field that says when it's been received, and it has other good information like when was the onset of the adverse event, what state are you in, how old is the patient, what sex is the patient, some long form symptom text, and lots more besides. Fields about whether the patient has died, whether it was a life-threatening or a serious or a disabling adverse event. A lot of information in there, but it's a flat file. So that's the VAERS data. It then has a vaccination table, or a CSV, if you like. That has a restricted sort of set of columns, and that's got what vaccination type it is. There's a flu vaccine there, Fluke 4. COVID vaccines are identified as COVID-19, and there are three manufacturers in the US. There's Janssen, which is Johnson & Johnson, Pfizer-BioNTech, and Moderna. Has a lot number. There's a lot of noise in there. It tells you which vaccine dose is applicable. So it could be dose 1, dose 2, dose 3, boosters. Again, there's some noise in there. And other data besides. And finally, there's a symptoms table. And these are basically the